Today we'll talk about lecture 23. This time I will continue to go through the code of root clan. I will show you how the root clan is implemented. I just want to tell you that any new APIs, any advanced APIs in grid free are implemented with the distributed primitives, DP, and existing advanced APIs. So let us continue here. And last time we finished here, right? There is a broadcast notify. That means this notification will be sent to all the children in tree-like topology. All the children in this tree will receive such a notification. So if you want to do that, you can just invoke this notification. Another one is async broadcast notify. If this method is invoked, then this notification will be sent to all the children in the topology or in this hierarchical structure. But different from this method, you can see here, this method, the notification is sent in an asynchronous manner. That's similar to what we have done for synchronous remote eventer and asynchronous remote eventer. Different from that when we invoke those two API, the notification is just interact between two computers. One is client, another server. But for this case, this is the multicasting, right? Broadcasting. So that's a difference. Another method here, this is also broadcast notified. Notification will be sent to the children in a synchronous manner. But different from this method, here the children are specified. For example, there is maybe the total number of children is 100 in such a hierarchical structure, but we only need to send some of them. So all the children case should be included, should be set as a parameter. So the parameter, one of the parameter of such a notification, you need to tell the root which children should receive such a notification. You need to specify them in a side collection. This one, similar to this broadcast notify to specify the children, but different from that, this method is running in a asynchronous manner. The same. Any cast notify. If this method is invoked, this notification will be sent to the children. At least one children in the hierarchical structure will receive such a notification. This one do the same thing in a synchronous manner. This one, the children should be specified. This one, the children specified, and the notification is sent to send in a synchronous manner. Unicast, the notification will be sent to specified children. There are a lot of children, a lot of distributed nodes in a cluster or in a distributed computing system, but only one of them receives such a notification. The one should be specified. If you do not specify the children, then the system will generate. For this method, no children is specified. For that, this method will generate will select one children randomly from the architecture and send the notification to such children. This one, unique. This is an unicast nearest notify. For this case, if you want to send a notification to you using unicasting, then the system will. This is the client. Right? This is the client K. This client want to send notification through this root. The root got this message. After it got the message, the root will select one of the children in this distributed system. However, how to select such a child, it's based on the K nearest, the logic distance, based on the K comparison. If the one K of the children in the architecture is the closest or nearest in distance, nearest to the client K, then such a children will be selected. This is this is such a method. This I just explained that sometimes this method is very useful because different children will if the message may be a task, so the task can be processed by one of the children, right? And the different clan had different case. Maybe such a distributed system have a large number of clans, and each clan, if using such a method, the task will distributed evenly to a distributed system. So it's a way to reach the goal of load balancing. So that's a very important method, and unicasting is very important. Sometimes we need to distribute data to all the children in a cluster, but sometimes in other case that just the sum of we need to distribute task if the data I'm sorry, if the data, in some cases, for example, the map reduce in the search engine, since the data is huge, right? A lot of the data is replicated. The data is crawled from the web page, from the website, 3W system. There are a huge number of websites, so we need to crawl all the web pages and index them. The indexed data will be distributed to a large number of servers. If we perform searching, the search query will be distributed to all the distributed nodes, so we can search all the data of the internet in such a way. This is one case. This is a broadcasting approach. However, in some cases, the message is one task that fulfill the requirements of the client. So, however, there are a lot of clients. So in this case, it's better for such a system to accomplish this task in a load balanced manner. So if so, it's not necessary. It's not necessary for us. It's not necessary for us to replicate such a message. We just distribute the message evenly to such a system, so each client can get the service from one of the children in the cluster. So there's another approach. So if we want to do that, just using unicast. Okay, in the later cases, I will program some program using the multicasting to design some applications. So at that time, I will show you some simple examples. I will program some upper level applications based on the new API. So and then I think you will understand the system, the method clearly. This one do the same thing, but however, the unicasting is asynchronous unicast notify. This method, if this method is invoked, this is also the data is also replicated to is sent to only one of the children, but the children is selected randomly, but this method is the message is sent in a synchronous manner. Async unicast nearest notify. This is another method. This is also similar to unicast nearest notify, but however, for this one, the notification is sent in a asynchronous manner. We just finished notification, right? Notify, because a lot of message is sent in two type of message in our system. We in the previous classes we focus on one-to-one interaction. However, for this case, we focus on one-to-many interaction. So in this case, multicasting should be employed. But even in this case, there are still two type of message. The first one is still notification. If notification is broadcast or multicast, then we do not need to collect any response from all the children in such a system. However, we have another type of message is also belong to the type of request, but in this case, I call it multicast request. This message, this API also new. I showed it last time, right? This one is similar to notification. If you want to send a notification, you just involve using this method, in this API. However, for this one, if you want to send a request through multicasting, you need to use this API, multicast request. Okay. Multicast request need to extend multicast message, need to extend this one, and then different from multicast message, the multicast request should have only difference. The unique difference is calibrator K. What does it mean? Calibrator K is used to represent one session. One session of request response based on multicasting. The calibrator, I just repeat, calibrator K represent one session of a request response based on multicasting. Each session have a unique calibrator K. This calibrator K is generated automatically. You don't need to assign, you don't need to manage such a K. This K is generated automatically. So based on such K, the root can collect responses from the children. That because such a request response can be performed concurrently. In a completely tuple system, the request response is processed concurrently. So if no such K, when the root, when the random point, in this case, the root is the random point. When the random point receives a response, collect some response from its children. If no such collaborator K, it's impossible for the root, for the random point, get to know how to differentiate all this message from each other, because all the responses from the children must belong to different sessions, belong to have different requests, have their own different corresponding requests. So such a key is very important. So when you want to send request through multicasting, you just need to use this API, multicaster request. This is another advanced API, right? However, you can see all the APIs are extended from the distributed ones, right? Distributed primitives. And if you this method is invoked, you will receive some responses, because a lot of responses will receive. So a list, a collection is returned. This message is sent in this request is sent in a synchronous manner. You need to pay attention to that, right? We have this one has a counterpart. This one sends message in a synchronous manner. I think this one is called a synchronous broadcast read. This one is called broadcast read. However, you must have questions about that. I'm not sure whether you have such question or not. When you perform read and perform reading operation between two computers, you can use the remote reader. You must remember that, right? Remote reader. This is one of the primitive API. However, when you do that, remote reader have a method that can perform reading and reading in a synchronous manner. But why we can do that? When we do that in a synchronous, using multicasting, we can do something asynchronously, perform reading action asynchronously. Why? You must remember, right? Remote reader, right? When we do that, only one method exists in such an API, read. This read can only be performed in the synchronous manner. However, for this case, we can do that in either synchronous manner or asynchronous manner. Why? Because this one I just mentioned in the previous class. And when we perform request response in a multicasting environment, in a multicasting based distributed system, there are no direct TCP connection between the root and most of the cluster. The root of the multicaster the root of the hierarchical structure only have a very limited number of direct children. The TCP connection exists only between the root and its direct connected children, right? However, such a system usually is huge, so most of the children cannot connect with the root directly. So for such read, it's possible it's possible for the root to send such request to its children in the asynchronous manner. If so, it must raise a lot of raise the performance. We don't need to wait. We don't need to wait. All the responses are collected by the rendezvous point. It's not based on TCP connection. All the responses are collected based on the rendezvous point, based on the another approach that's different from the remote reader. When we use remote reader, there is a direct TCP connection between the client and the server. However, in this case, no such direct connection, no such direct internet connection. So maybe the root need to send, maybe he has 10 children and direct children. So this message is sent, there are 10 direct connection, TCP connection between the root and the children. So the data can send it to the children one by one. It must be slow, right? It must be slow because we need to wait all the connection to finish we must wait for some time before the root can send 10 messages to its children. But however, each of the children do not respond to this root directly, even there is a direct connection between the root. The children, no matter whether the children have a direct internet connection with the root or not, all the children in the hierarchical structure need to send their response to the rendezvous point. Each children need to build another connection to the rendezvous point. So in this case, it's better for us to use a synchronous read. So it can raise some performance, right? So this is a different approach to send a request and collect responses. That for the multicasting in a large-scale distributed system, the broadcast read and the read and action, the read operation is performed in different approach. That's why we have different manner to send such a request. Okay, another one is unique read. Unique read, that means for this case we specify the child K, and then this request will send to the children, and the children will respond to the root. It's another approach. You can say even only one child is selected, the return value is still a collection. That means that such child still need to send their response to the rendezvous point. The rendezvous point just create a collection. He has no idea how many responses will be responded. How many responses for such session will be collected. So it just create a list. So this, according to this method, you can also understand that a remote reader is not used. You must have remember here, right? Only SRE, synchronous remote eventer, is used. I do not even use a synchronous remote eventer. And the remote reader is not also used when we interact with the children, right? So, okay. Broadcast read. In this case, the broadcast read, that different from this one. For this case, the children should be specified. So only those children in such a system will send responses for such a request. Any cluster read. So you can specify the number. The number is n. That means you hope the least number, the minimum number of children that will respond this request is n. This is the least number that of the children that will respond to this multicast request. Any cast read. This is a synchronous response. Sync any cast read. These two approaches are similar to each other, but this mass request is sent in the asynchronous manner. This sync read, the request is sent the synchronous manner. Okay, this one need to specify. This also any cast read, but the children is specified. If at least one of the children will send a response. For this method, unicast read. So this one, the children is selected randomly. Select randomly. One of the children will select randomly from the hierarchical structure, and then after this request is received by such a children, the children will send this response to the randomer point, and then the response is generated, can be obtained. Unicast nearest read. Here the client key should be specified. So if this is similar to the method unicast nearest notify, they are similar to each other. So based on the client key, the request will send to the nearest children based on in terms of the key comparison, and then response will be obtained from such a child. This is performed in a synchronous manner. This one, another one you can see here, right? Here, this one called a synchronous unicast nearest read. For this method, the request also processed only by one of the children. Only one of the children will process this request. But this one is the message is sent in the asynchronous manner. This one is the last one. This one is similar to the unicast read. Asynchronous unicast read, if the key is not specified, if the client key is not specified, if the child is not specified, the child will be selected randomly. Okay, this is the root clan. Oh, this is the method you can invoke in your application. According to the introduction, I think it's this method is easy to be used, right? So you must wonder how this method is implemented. That's a very important topic when I discuss some details, the techniques of grade 3, right? The details of technique of grade 3, because I want to enter such a method, enters the API, each of the class in such API. I want to explain how this method is implemented. To prove, the reason I want to do that, because I want to prove that distributed primitives in grade 3 can be used to implement all the advanced APIs that we do not have. If you want to implement some new APIs, just use distributed primitive API and existing advanced API. Okay, let us take a look at this. There is a remote eventer. We take a look at this first. Remote eventer. If we open this method, you can see some method here, right? Some method you can see here. There are a lot of methods. This method is invoked here, right? If you want to perform read action, you just invoke the method from the reader, root reader. If you want to send a notification, you just invoke the method of root eventer. Let us take a look at this. This is eventer, right? You're using root eventer to send a notification. You can use root reader to send a request, right? In a multicasting manner. So let us take a look at this first. Because we have no so much time, so I also think most engineer must feel boring to look at the code inside. So I just gave you a general introduction. I gave you a rough idea. So you can, if you are interested, if some of them you are interested in the details, you can do some research carefully. But in this class, I just go through them, give you an overview, right? A general understanding about my technique. Okay, let us open this one first. This one is important, right? This one is called RootSyncMulticastor. According to the name, you might understand what's going on inside for this class. After we open this, you can see here, this is a very important API for RootSyncMulticastor. You must be familiar with this API because it's one of the API of distributed primitive, right? This attribute is fine. This one, another one is a root renderer point. Root renderer point is one of knowledge we need to use to program a multicasting in a distributed system, right? So this knowledge, the root branch count, the tree branch count, and the root renderer point belong to the distributed knowledge for multicasting. So when you want to implement a new API, you just use distributed primitives plus the distributed knowledge. So you can understand such a system, right? So you can understand one of the most important feature, one of the three most important feature of grid free. Okay, you see such. Let us take a look at the constructor. The constructor contains 3 parameters. If you want to initialize RootSyncMulticastor, you need to initialize the sync remote eventer, right? Sync remote eventer need to have a free client pool, and then the 2 parameters, root branch count and the tree branch count should be initialized. Okay, and then the renderer point. Let us take a look at the renderer point, how to implement such API. This is this API. In this API, there are nothing related to distributed techniques, right? So you can see here, This is you just use some Java to describe your distributed knowledge. Such distributed knowledge is just describes just similar to upper level application. It's similar to upper level application based on distributed primitives. This is but this upper level when you for example, we have programmed some projects online. You have ever see some examples in our previous classes. When you program a distributed system using Godfrey, you have two portions of work. The first one, you need to use distributed primitives on other distributed APIs to construct your distributed frameworks. And then you need to create the upper level application. For example, the chatting, the e-commerce, file transmission. This one, the reservoir point, can be understood as one of the upper level application. However, for this case, this upper level application is one type of distributed knowledge. With the distributed knowledge, you need to implement to perform multicasting over distributed primitives, right? So here you can understand this this API, the reservoir point, root reservoir point can be regarded as one type of upper level application. Although we call it distributed knowledge, however, you can see here the code is easy, but the code is nothing to do with any distributed environment though, right? It's just based on some knowledge about reservoir point. You just describe reservoir point, right? Okay. There is a class here, multicast point, and in this class there's some messages, right? Some messages should be is contained here, and one important field is a collaborator key. You must have CSET key here, right? Collaborator here for multicasting request. So the multicasting point contains the same key. So each session for request and response based on the multicasting have a unique collaborator key. I just mentioned that, right? So to save time, I just want to know that this reservoir point is generated is used when we need to collect the data, right? Collect the responses. So if the responses is received, then the response is sent to the points, the multiple points. This is the map. So according to the calibrated key, all the message are collected. You can see here the response is collected, right? Until maybe the we have got enough all the messages, right? If all the messages are received, then we can take a look at this. If all the messages are received, this method will be invoked. This is signal. You can see here, this is signal. Oh, sorry. Signal. There is a think. This method, I'm not sure whether you're familiar with that. This is the API I created using the think. The different the thread on the underlying thread can be synchronized based on notify wait approach. So to save time, I just want to tell you that when sufficient messages are received, is full, right? It's full, and then the signal will be sent, will be notified to the thread that is waiting for all the messages. So after this one is executed, this message is invoked. That means all the response is received. All the responses is received. So, however, fortunately, you do not need to care about the details. You do not need to care about details if you are just want to use upper level application. If you want to just use upper level application based on my API. If you want to know some details, if you want to understand the technique of my techniques in detail, that you need to, maybe if you are interested in that, if you want to improve something here, and I think you can do some research here. So this one is a rendezvous point, is a API that based on there's nothing new in this class, right? This is the one type of distributed knowledge. So here, let us take a look at this one. For this multicaster, this method must be complete, looks complete, right? You can see here, notify. This method is difficult. And for this one, nearest notify, this just because there are only one-to-one mapping, right? For the unicast and the random, for this one is random, notify. This one is the nearest k, this one is nearest notify. For such notify, the message sent from the root to one of the child, only one of the child. So the message is easy because the single remote eventer, using such remote eventer is easy to do that. However, if we want to send the notification to a lot of children, for this case, a larger number of children need to receive such a notification. In this case, we have to build a tree. You can see there is a tree. This class is also implemented by me. Like this, I don't want to explain detail for this class, but it's easy to be understood. You can see there is a method called construct tree. Using this API tree, you can construct a tree. This is the tree, right? Using this tree, you can send the data in a hierarchical tree like hierarchical structure. You need to tell the root branch count and the tree branch count, and you also need to tell the method, another parameter is the children, right? All the specified children. So using this parameter, a tree will be constructed. So when we build a tree, that is nothing to do with any distributed techniques. You do not need to understand. You do not need to worry about the underlying distribute, the network with concurrency, the resource management, and anything, the distributed architecture. It's just construct a tree. This is there are a lot of mature algorithms. For example, in data structure, and some classic textbooks of data structure, and the classic books about algorithm. There are a lot of details to tell you how to construct a tree. So this one is nothing to do with distributed programming. This can be also understood as the business logic on the application level description, right? So if the tree is constructed, then we can send the data. We can send the data in a loop. Here, there's a do-while loop, right? There are do-while loop. In such loop, the root, because it's a RootSyncMulticastor, right? So the root can send the data, send such a notification one by one. The data can one by one to its directly connected children. This loop is used in this way. So I will not explain that in detail. You can see here, this is the exception. The exception means maybe one of the children got failed. So we just remove them and perform some fault tolerance task. This one, if every child is fine, every child was fine, then we just send following each step in such a loop. The data will be sent to the children, its directed children, one by one. Okay. This is another case. In this case, the children is not specified. All the children should include to construct this K. The children case is not specified. All the children in the system should be constructed within such a K, within such a tree. You can hear all the children, right? The inventor, the root knows all the children. He can get the children from the inventor. Okay, then after tree is constructed, this is for testing, right? So you don't need to worry about that. And for those is code here, that's similar to the previous class. There is also here, after tree is constructed, there is a loop, do-while loop here. The code structure is the same. Here, the inventor will send the data to its direct connected children one by one. The code is almost the same. This one is to perform read. For this case, we need to different from the send notification because we need to get a response. We need to get a response for this case, right? Thus, here, we need to define the size. If the random read, what means random read? Random read is belong to the unicasting. The read is performed based on unicasting. For this case, this RP is the random point, right? For this case, for this collaborator K, only one response is necessary. So we need to set such a value in the random point. So based on this, if one response is received, then the unicasting read is finished. So that's different from the notify because we need to use random point. When we even we use this is the read, we still need to use the inventor, the synchronous remote inventor. We do not use remote reader. You can see here, right? Remote reader is not used. We still use the synchronous remote inventor because I just explain how the request response is performed in a large-scale distributed system. It's different from the scenario of remote reader. is used. When we use the remote reader, only two computers, one client and a server, TCP connection exists between them. So I explained that before, right? Okay, this is the same. Nearest read, the same thing. Okay, this one, read, child K. This is also unique cast. Okay, this one may be difficult, a little bit difficult, right? Here, we need to specify the responses. We need to specify the number of responses. So here, for the responses, because we need to specify the number of responses, we just need to tell the random point such a number. Instead of 1, this is 1, right? However, for this case, it's n. And then we need to build a tree again. That's the same thing, right? We have done that before. And then we can, send, after tree is built, we can send it to the children. The root can send the data to the children directory. Okay. And, okay, that's the same thing. And then we will take a look at the child client later. So this is root client. And this is also almost the same. This is, okay, I'm sorry. For this case, for this read, the children case are specified. So we just need to, so the size of the children is identical, equal to the set of responses. Then we need to construct a tree based on the specified children. Then we send the data using sync remote eventer to send a notification. And for this case, it's the same, similar to the previous classes. A method, the children key are specified, but the number of response is also specified. So here we need to set a size of responses in the random point, and then generate a code, generate a tree, and send the message. This one may be more general, right? So all the children, this is a broadcast-based request response. So broadcast based on read operation. So set the size in the random point. All the children should send responses, and generate a tree based on all the children case, and then send a notification. Okay, send a notification. Okay, so that's very important API. That's very important API in when we implement the new advanced API for multicasting. This is the kernel one. This is a kernel one. So after my implementations just now, you can understand that such a system, when we implement RootSyncMulticastor, no any third-party distributed APIs are employed, right? The only API you used for distributed system is sync remote eventer. You do not use any other distributed related API. The remote the RootSyncMulticastor is completely based on DP only, right? Only one of the most important API used in DP is a sync remote eventer, and then for other code, for other in addition, you also need to describe the discrete knowledge, the upper level application description. You also need to do something actual work on distributed knowledge. Then you can create your own distributed system. Create your own new advanced API. This one is a little bit complete because the distributed knowledge, the multicasting, the environment of the multicasting is a little bit complete, more complete than what we have seen in the previous classes. So this code is long and some details, contain a lot of details. But anyway, you can see the new API, RootSyncMulticastor, has nothing new in terms of distributed techniques. So if so, if the multicasting I just mentioned in the previous classes, if multicasting is one of the important API for large-scale distributed system, multicasting is a primary approach for us to establish large-scale distributed system, to establish scalable distributed system, right? To enlarge the scale of distributed system. If such API, the kernel of such API contains nothing new, but distributed permitted API of grid-free, that another evidence that also prove that grid-free is self-contained. Okay, I think there's still some other code I need to explain in the next time, but I think I have already finished the most important one. This is a RootSyncMulticastor. I will explain some other related code in the next classes, and I also need to explain the the child client in the next classes. Okay, I hope I can start to program after the explanation. I think programming with the code is more, it's a new API is more interest. I also need to show the demos, how to run such a, give you an example, give you, because I build a framework. After this one, I will run this framework for you, show the demo for you, and then I will program some applications based on the multicasting environment. That's what we will do in the near future classes. Okay, thank you so much. If you have any questions, just let me know. That's all for today. See you next time.